the beam. So the beam is this big, right? And you might do fluorescence imaging to image the whole illuminated area and so on. There are very many things we can do. That is why we have this telescope. Those of you who were in Mali remember we were operating like this, but it was much more primitive because the laser was much weaker and we only had rubber bands and tape to fix. Still, we saw the first fluorescent spectra remotely in Africa, I think. Yes. Pardon? What comes here is not very dangerous to the eyes, actually, because it's spread quite a lot here when it is like that. If it's a pulse laser, the class for the pulse lasers, of course, it's quite a lot of radiation in each pulse coming out there. But it can be quite bright still, these things here. And it would be very dangerous with something. This is scattering very diffusely, very diffusely. But if it would be a piece of metal or anything that could throw something which is, not exactly a beam like that, but divergence. So we need to be careful. And I just would like to tell you that if this had been in the visible, say some of you have a green laser, this would have been absolutely blinding light. Our eyes are very bad at 405, right? So it's much, much more than you believe. Han fick loss där. Ja, jättebra. Så då kan vi titta på byta ut den då. Så då kopplar vi. So now we will demonstrate. Abuma managed to get off the lens. So now we will do exactly the same thing without the lens, and then you will see a strongly divergent beam, and we will demonstrate that first also. Well, it depends.